Hi everyone, and welcome to our ACT geometry review. Today we are going to review geometry questions on the ACT. ACT questions always include geometry, so here we go. Let's try a few. On the first page, we have a diagram that shows two circles. One is circumscribed inside the other. So the circle that is in white obviously has a radius of 6. And the circle that is shaded in gray has a larger radius than 6. It has a radius twice of p, therefore the radius of q is 12. Now for those who don't remember what radius means, it means half the length of a circle. So the diameter is the full length from one side all the way to the other, and the radius is half of that. The formula for finding the area of a circle is pi r squared. Pi r squared. I'm gonna write this out. Pi r squared equals the area of a circle. Now in this circle, 6 has to do with the smaller circle's radius, so let's figure out the area of this small circle first. So pi and then 6 squared. If we square a number, we multiply it by itself twice. Therefore, 36 pi is the area of circle P. Now, the area of circle Q is going to be the same formula, but this time the radius is 12. So 12 times 12 is 144. So pi r squared will be pi times 12 squared. We have 144 pi. Now to find the area, we're going to have to subtract the area of the larger circle from the smaller circle. And 144 minus 36 is equal to 108 pi. That is the area of this entire region. Therefore, the answer is D. Okay, on to the second question. This question is a which must be true. These questions are a little complicated because there are things that could be true, but we only care about what has to be true in all circumstances. Now, this would appear to be a transversal, which we don't know for sure because they didn't tell us. A transversal would indicate that these two lines here are parallel to each other and they cut through this line here in the center. But we don't know if that's true. But we do know some principles about vertical angles, which is any angle that's vertical has to be the same degree. Therefore, the vertical angles that we have here are B and C, as well as A and D. What does this mean? This means if A is, let's say, 80 degrees, for instance, that means that D will be 80 degrees. Because they are opposite each other, they are vertical angles. And if A is 80 degrees, by default, B has to be 100 degrees because a line is always 180 degrees. Which is also the same for a triangle. A triangle is always 180 degrees. So this one has to be 100 degrees. Now let's look at the choices here. They're saying what has to be true. Either angle A is congruent to D. Well, we just said that's true. So that's our answer. Now they're saying here angle A is congruent, angle A is congruent to angle E. That might be true if this is a conversal or a transversal. If it's a transversal, then corresponding angles are congruent, which means these opposite angles, these opposite interior angles. So A would be congruent to E if this is confirmed that it's a transversal, but we don't know for sure. Same thing for B and F. They would be congruent if this is confirmed to be a transversal. All right, let's move on to question 3. Here we have a man that is standing 20 feet from a light post, and he is 6 feet tall, and he leaves a 10-foot shadow. Nice enough for us, they drew an image. Sometimes you'll get questions like this and they expect you to draw an image yourself. So the first thing is we're going to have a triangle and we want to know what the base and the height is. And we want to be able to find the height of a lamppost that is nearby, right? So the way we're going to do this is set it up as a proportion. First, we're going to say that we have similar triangles and we're comparing them. So let's put a dotted line here. Oops. Now we can separate this as two distinct triangles. You have an unknown height of this lamppost, but you do know this triangle, 6 feet right here, and 10 for the base, and we have 20 for this base. But altogether, the length of this, right, is going to be 20 plus 10, which is 30. So if I were to draw two separate triangles, this would be 30, and this would be x, and this would be 10, and it would be 6. So we're going to set it up as a proportion. X over 30 is equal to 6 over 10. Then we're going to cross multiply these and solve for x, which is the height that we don't know. So 6 times 30, we have 180. 10 times x is just 10x. We divide both sides by 10. X therefore equals 18 feet. And that is the answer for 3C. Okay, number 4 on this page. This last one, we have to think of triangles again and their properties. We're told that triangle ABO is reflected over the x or the y-axis. Then the triangle is in quadrant 2 is reflected over the x-axis. What is the perimeter of the 3 triangle area? Again, they gave us a drawing, which was super nice. And we also can tell what kind of triangle this is because both sides are the exact same length, 5 and 5. We only have this in isosceles triangles, isosceles right triangles to be exact. What that means is if this is an isosceles right triangle, we have x and x and x root 2. Now x in this case is 5, so by default, this side will be 5 root 2. Now, since I already drew this, I'm just going to show you the adjacent page, what this image should look like so we can figure out the perimeter. Here we go. As you can see, the perimeter here is going to be, let me just move this. Okay. The perimeter is always the addition of all the sides. So if this is 5 root 2, this will be 5 root 2, this will be 5 root 2, and then we're going to add 5 plus 5 is 10. So 10 plus 5 root 2, 5 root 2, 5 root 2, that gives us 15 root 2 plus 10, which is our answer, choice A. Thank you for watching.